Hello and welcome to the Daily Space for today, Friday, October 4th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. I am coming to you from an unusual location this week. I am out in, oh my goodness, it is so hot, Tucson, Arizona, where they are painting the building outside the window beside me. So if you hear any odd noises, I do apologize in advance. This is one of the side effects of doing a live show. I am currently out here visiting the Planetary Science Institute headquarters, and I will be giving a talk at the Flandrau Science Center tomorrow, Saturday, to help celebrate International Observe the Moon Night. We will be live streaming, Wi-Fi willing, the presentation right here on Twitch. So prepare to tune in at 7 p.m. Eastern. That is 7 p.m. Pacific, 10 p.m. Eastern. I believe that makes it 3 a.m. London time. Apologies to Europe. So today we have a variety of different news stories coming to us from all over. Many worlds, including our own. Our first story for today is one of the origins of life. Now, if you've been working on keeping track of the timeline of the development of our own planet Earth, it's time to pull out your erasers, wipe out that penciled in date you have for when life first started, and write it in with pen. We now have multiple lines of evidence that make it appear that stromatolites found in Western Australia not only date back to 3.5 billion years ago, but are also the fossilized remnants of life. Stromatolites in general are these really weird rocks that are formed through the secretion of lime and other calcium-rich minerals by different kinds of cyanobacteria. Put another way, they are large piles of cyanobacteria poop. And they build up these really cool rocks that also contain, well, elements of these microbacterial mats. Now, we see these forming rarely, but still forming today. And unfortunately, though, there are those who think this isn't the only way you can get this kind of a rock. And so when we find stromatolites and someone says, hey, this 3.5 billion year old rock is evidence that life existed on Earth 3.5 billion years ago. People want more lines of evidence than just, it looks like a fossil. And we finally have it. This is something that people have been looking for since the 1980s discovery of these rocks. And what they found is trace organic material left behind by these bacterial mats. And here I have a quote from the lead scientist of this article that has appeared in the journal Geology. And this is from Raphael Baumgartner. And he states, "The organic matter that we found preserved within pyrite of the stromatolites is exciting. We're looking at exceptionally preserved coherent filaments and strands that are typical remains of microbial biofilms." Now, it's the timing of these fossils that really caught my attention. 3.5 billion years ago on Earth is a long time ago, but in our solar system, it's a really cool time. This is the point in our solar system's history where it's now thought that both Mars and Venus had vast oceans. And if the oceans of Earth were capable of supporting microbial films that led to the formation of stromatolites, well, maybe Mars and Venus had the same things too? And we've already seen rocks on Mars that look kind of like stromatolites. Now, like I said, looking like stromatolites is not enough evidence, but it's tantalizing. And I could go on all day about this, but I'm not going to because this is a news show, not a wild speculation show. Okay, moving from Earth outwards towards Mars. We have more news coming to us from the InSight mission. For those of you who have been following along, This mission has two primary instruments, a seismograph that we discussed yesterday, and also a thermal probe that was supposed to get driven meters beneath the surface of Mars, but instead it got stuck about 35 centimeters below the surface. Now, why exactly it initially got stuck, we're not entirely sure. It's thought maybe it hit a rock. But whatever happened, they can't get the probe to move. And part of the problem is this system works by having a hollow tube that they draw a hammer back, and then they hammer the hammer down, and it's that hammering motion that drives the probe through the Martian soil, or in this case doesn't. And the problem is that it has to be frictionally held in place while they draw the hammer up, or it's just going to move, or in this case not move downwards. And they think that there's now a hollow that has developed, a cavity that has developed around the probe. And the illustration that you're seeing is they tried tapping the soil next to the probe. You can see the top 5 centimeters of it coming out of the soil. They tried tapping the soil around the probe to get the dirt and debris to fall down around the probe, and the dirt and debris did not do anything. There apparently is a very thick crust that doesn't like to be broken, that is above a sandier soil. They're still stuck, guys. They're still stuck. Now, the next thing they're going to try and do to get their thermal probe unstuck is they're literally going to take this shovel from the inside and wedge it up against the side of that probe and hope that the force sideways from the shovel is enough to get it to get the friction that it needs to drive itself downwards. The creativity going into trying to unstick this probe is truly awesome to watch. And I have my fingers crossed for these guys. Okay, moving on to our next story. Since it's Friday, I wanted to end the episode with something cheerful. And we have something cheerful thanks to Hayabusa2 and its tendency to drop things on Ryugu. It has once again dropped something on its asteroid. And this time it was the Minerva II rover. This is a hat-shaped or a hat-sized probe that got released from 1 kilometer above the surface last night. And when it was initially dropped, it was falling at a whole 6 inches per second, which is way slower than you can walk. And the reason for this very slow descent is there's just not a lot of gravity out there. And as Minerva slowly descends towards the surface, it's actually going to be working to try and measure that gravity field. And what's cool about this particular drop is the Hayabusa2 has been tasked with taking a whole bunch of images as it falls. So we can hopefully see images of Minerva as it descends on the Twitter feed of Hayabusa2 throughout the weekend. So this is the last big step for this little mission. After this, the next thing it does is it comes on home. And it's bringing with it a soil sample. And we're going to get to explore the dirt of an asteroid. Now, this isn't exactly news, but I do want to point out that a lot of our news comes to us from spacecraft. And the very first spacecraft, Sputnik 1, orbited our world 72 years ago today. Launched on October 4th, 1957, Sputnik 1, it was able to operate on batteries for 3 weeks, and during that period it let off a whole series of radio pings that could be detected by ham radio operators the world over. Now, what always amazes me is everything that we've accomplished in space exploration has been accomplished in just 3 generations. So to go from this little tiny satellite to the massive human-holding International Space Station in 72 years, it's been a wild ride. And who knows where we will go in the next 70 to 100 years. And we'll be here to bring you the next few of those years right here on the Daily Space. And that rounds out all I've got for today. I am going to hang around and answer your questions right here live on twitch.tv. While you type them in, I'm going to remind you, please use the emote that is a purple circle with a star in the center, and that will help me find your questions. And if you ever miss our episodes live here on Twitch, you can always get them over on YouTube at youtube.com/c/CosmoQuest. We are here thanks to you. And we are also here thanks to our producer, Susie Murph, who is the great cat herder of the week. And I'm so grateful for everything she's done while I'm traveling, and Annie has been picking up the pieces, and we are making this all work. Now, we are taking next week off. I'm going on vacation. The podcast edition of this show will continue. So I'm sorry there won't be any videos, but we come out as a podcast now. The Daily Space, you can find everything over on dailyspace.org. We are a production of the Planetary Science Institute, and we're here to explore our solar system and beyond and take you with us. And right now, I'm just going to answer your questions. So here I go looking for questions. Let me switch screens so I can get the questions a little closer up to where I can see them. We are going to be doing a live episode of Astronomy Cast later today. It is going to be a double feature with recordings of an episode both on the expansion rate of the universe and the age of the universe. So you will be able to see that here in an hour and 45 minutes. Okay, let's see what we have. Thank you for the bits, Wayne Johnson. And Larry, don't leave your cranium open for too long. You don't know what you're going to catch that you don't want to. Oh man, it's already freezing up there in Germany, Guido. I would gladly send you some of our heat, but that might do bad things to the environment. Hello, Ironheart. Yes, DPI 209, Stromatolites. They're cool. Thank you, Kevlar1066 for the bits. Hello, Michael. It's a grandpa satellite. Yes, Sputnik is indeed a grandpa satellite. Thank you for your bits, Checker Kev. There are not questions today. No questions? Your brains are all full. It's Friday. You're ready for the weekend? Oh, Michael is saying, self-hammering probes seem to have trouble. The one that Philae had didn't work either. It's true. It's true. So Susie's asking, what were the topics for AC today again? We're going to do the expansion rate of the universe, things we thought we knew, we actually don't, and the age of the universe, also things we thought we knew and we don't. Yeah, the Stromatolites are completely amazing. I too was stunned by the Stromatolites. It's just cool to think that life was already forming 3.5 billion years ago. And it's going to be really heartbreaking in a way if we discover Mars currently has no life at all, but when it had oceans, it had the same life that we had here on Earth. Who knows what we'll discover. So Fenmel asks, how much longer till the sample try for Osiris-Rex? I should know that, and I don't. I am going to be sending out newsletters later today. Folks who mapped out the areas that were part of the sample selection regions will be getting messages. After I've sent all of those out, I will be sending a message to everybody saying those emails went out, and we're going to be looking to get people's publishable names. We are also reaching out to a small group of people, the top of the top number of markers, and next week phase 2 of Bennu mapping will begin. Your data all confirmed. You guys are awesome. Oh, Walker, I understand still being sleepy. I'm still drinking my coffee here. I saw an article about a quark, and I basically decided it was not evidence driven. I was moving on and needed more coffee before I dealt with particle physics. Hello, Broken Symmetry. I'm not sure I've seen you here before. Welcome. Broken Symmetry asks, wouldn't some of the light from the original Big Bang be lost to observations having been absorbed or dissipated in a smaller area of space-time? Okay, I'm going to try and unpack that a little bit. So, when our universe formed, it was nothing but energy. It was hot, it was dense, and as it expanded, it cooled. So if you have something that's very dense and you expand it out, it cools. The dust spray air you use on your computer, same thing happens. Now, as the universe cooled, it eventually cooled to the point that it could begin to have nuclear reactions. It eventually cooled to the point where suddenly it went from being so hot and so dense that light couldn't really get anywhere. It was constantly being absorbed and re-emitted, to, at a moment, the universe hit a temperature where the free-flying electrons were able to glom on to atomic nuclei and form neutral atoms. And this changed the density of the universe so that light could suddenly fly out in all directions. And this means that this piece of space sent light in all directions, and this piece of space, and this piece of space, and every piece of space sent light in all directions. And when we're observing the cosmic microwave background, what we're seeing is the shell that is around us of all the places where the distance is just right, so that light that started 13.8 billion years ago minus 400,000 has had time to travel through space and get to us. Now, we also gave off that light, and that light is reaching any observers that are located where we see the CMB. But the thing is that every intermediate point also did the same thing. It's just that light is either shot past us or hasn't got to us yet. So the CMB that we're seeing is just a function of where we are in the universe. And it's not the only CMB. It's just that shell of light that is geometrically in just the right place for us to see it. The best way to think about this is if you've ever walked around in a fog, you can only see a certain distance around you. But as you move, you're seeing not the same wall of fog, but you're seeing a constantly changing wall of fog. Well, we can't travel noticeable distances through our universe and see changing walls of CMB. We see what we see. Now, from what we see, there are places where galaxies have absorbed out light. We call that the Zhenijevskii effect. There are temperature fluctuations inherent in the universe itself. There are places where even like the dust around our solar system has absorbed out light. It's because it's light. Things get in its way. But that's a local effect, and physics isn't local. I have no idea if I answered your question or not. Please ask more focused questions. I need more coffee. Okay. Mythtown is gifting a sub-1 to the community, and it went to Zine, who's one of our longer-term community members. Enjoy that, Zine. Michael asks, when the light was emitted, the universe was much smaller, so the light should have got to us from everywhere quite soon after it was emitted. Not quite. So the universe was much smaller when it was emitted, but the universe was expanding. And we've always been getting cosmic microwave background light, but the light that we're getting hasn't always come from the same point in the universe. And so it's one of these double-edged problems of what we see now isn't what we saw then, because geometry. And since every point was giving off light, when we move, we're still going to see light. When time transpires, we're still going to see light until all the light is absorbed up. I don't know if that helped. So yes, we would have seen cosmic microwave background light at every point in history, just we would have seen it coming to us from different points. It's hard to explain some of these things. Yeah, never discount the expansion rate of the universe. That is entirely true. Yeah. Okay. Do we have any more questions out there? I love that Fenmil is like the most devoted advocate of the Mineral Cup that is going on Twitter. For those of you who haven't seen this, it is a bracketed competition where you get to vote for your favorite mineral, coming from a variety of different categories. And I don't know the current step, but it's really fun to watch. Mythtown asks, isn't the expansion rate speeding up? Yes. Dark energy. Don't ask me what it is, but it does appear that the rate at which the universe is expanding is speeding up. We'll talk about that today in Astronomy Cast. Other questions? Anyone? Okay, so Dino Cup is about to start and Mineral Cup is over. Ah, man. I'm so bad. Oh, small correction on Sputnik. It was 62 years ago? Wait, 57? 57 wasn't 72 years ago? No, because it's 19, not 29. I can't math. This means I need to re-record part of our podcast. That makes me sad. I may just omit that from the podcast. I clearly shouldn't be trusted to math before I've had coffee. Thank you for the correction. Math fail. Thank you. More coffee, less math. I appreciate that notion. I really do. But this now explains how I know more people than seem to be reasonable who remembered Sputnik. Do we have other questions out there? I think there's a lot of people who are going, I was born that year. I am not that old. Fenmil's offering to dog sit. So this is a girls' vacation. My friend Salen and I are taking her children to Disneyland. So my husband was left behind. Her husband is on a business trip, girls' trip. A Lego Sputnik sounds like an excellent thing to make. So light cones. Mike Cassidy, give me a context for light cones, because there's different contexts. I need more information, and then I'm happy to explain. I just need to know which you want me to explain. So Larry was alive for Sputnik, but doesn't remember it. That's cool, though. It's cool to be able to say you've been alive for the entire space race. Oh, I see no more questions coming in. Okay. If there's no more questions coming in, I am going to look to see who is around to potentially raid. Who is there to raid? Rocketology? How do you feel about Rocketology? They're doing station construction. DOS is live. Oh Brother is live. Thank you, Kevlar. Okay, let's do Let's do whoever has fewer people watching. That's Rocketology right now. So we're gonna raid Rocketology, and I'm going to wish you all a wonderful weekend and remind you again, it is International Observe the Moon Night. Find a local event if you can, and if you can't, well, we're going to try and do some stuff right here on twitch.tv. We are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. Thank you for being here and always being the support. And wherever you are in the world, have a fabulous morning, evening, or afternoon. Bye-bye.